Namaste and welcome to KADEC Learning Series. These are the highlights of the KBE Workshop held on 13th September. This KBE Workshop was for champion users and it covered why generalized model is required, how to plan the master model, modeling strategy, then implementing the strategy, and then testing and configuring the model. So the generalized model is required because CADEC is a configurator which is based on object-oriented concept. So everything about everything of the design should be generic. The inputs, model, drawings, calculations, lists, etc. The alternative to generalized approach is having many special cases and they require repetitive and manual design process. If you don't want to do that, then the only approach is a generalized model. By doing a generalized model, uh, it is also useful for design standardization. For planning master model, there are four things. One is the variations. So we need to write down the variations. Then we need to separate the shape and size variations. Shape is the features and parts which can be suppressed, unsuppressed, and size is the dimensions. Size is easy, but shape needs some uh, good thinking, and the shape variations need to be exclusive. So then you can make different combinations of different feature sets, and we are planning the geometry, not the CAD model. So, second part of the mass modeling thinking is the nomenclature. So, basically, every generalization starts as a thought about it. So, you need to uh, make your own nomenclature or your own ways of defining different variations of your own product. And if you discuss with your colleagues and you can, if you refine it, then it becomes a better generalized approach for the master model. Here are some examples of nomenclature. So this is a process tank. So you can see different legs, then the tank, then different nozzles, top and bottom closure. So connections can be a generalization of various nozzles, thermowells, trunnions, side classes. So connections is a nomenclature created for generalizing the different nozzles, etc. Then top closures can be generalization of different top closings like flat, toroidal, inclined, top, etc. Then bottom closure can be a generalization of flat, conical, toroidal, etc. And so on. Then this is an example of nomenclature of different conveyors. So conveyor type is a nomenclature which covers either roller, slat, belt, etc. Then the movement is a nomenclature which covers manual, powerized, etc. Then here is an example of electronic enclosure. So it's a fabricated structure. So if you want to generalize it, then you can think of different subsystems, that is base, walls, roof, compartments, internal components, etc. And you need to generalize the doors like single or double, etc. Then this is a nomenclature for the hydraulic cylinder. So the action can be a generalization of either single or double acting cylinder. Then fitting can be a generalization of either welded or tie rod. Then mounting can be on lugs. Then uh, various flanges, clevis, pivot, etc. Then cushioning, port type. These can be again some nomenclatures. This was an assignment given to the champion users who attended it. Then we need to plan master model. So first is plan the parts. So think of the entire system in terms of subsystems or components. Try to define the end usage from the end usage point of view. Think of the interface between different parts and not mates. Consider orientation of the components in the main assembly. This example of a crane, how to define the parts. So if you visualize a crane And you can think of the components required like rail, end carriage, girder, hoist, platform, etc. Then the parts like end carriage is not a part but it's assembly, so it will have web plates, flanges, wheels, geared motor, etc. So for everything we need to define nomenclature. Like for a crane we need to have a nomenclature like wheelbase, web height, frame width, thickness, etc. We need to also think of which part is the parent of which part. Okay, and the orientation of the part also needs to be defined before we think of modeling it. For example, the girder will always have will be along the front plane and so on. Then we need to, after parts definition, we need to also think of the features in each part, in each important part. So we need to decide the part orientation, simplify the part if possible, then think of the functionality and not the feature. Think of parent-child relationship within the part, that is, which boss will be the uh, parent or child of which plate, etc. We need to also think of dimensions of important features. This is an example of a defining features of a girder. So it can be of different shapes, that is either I section or box section. Then it will have plates, ribs, stiffeners, end cuts, etc. Once you have thought of the parts, features, etc., and you have done your own nomenclature, and you have thought of your shape and size variations of your product, then you need to write down the modeling strategy. So, modeling strategy is a tabular format in which you define the sequence of the features. Then, for each feature, you specify which is the profile plane. Then, if required, what is the path plane, then define extent of the feature, then parent child relationship. So this is how you can document the modeling strategy in a tabular format. This is example of a modeling strategy of a festoon. So the festoon is assembled using different bought out components. It will have cable, uh, then it will have various supporting members, etc. This is a modeling strategy of a base frame for a structure. So it will be a rectangular frame of large enclosure. So outer members and main internal members are primary members. Then secondary members will be along the length or width, the mid members. And you need to define the strategy first. And this is the more detailed strategy for the same part. So primary members, customized weld element profiles, and other secondary members, etc. This was the assignment given to the users. Then we need to implement the modeling strategy. Whatever was planned needs to be implemented. It is also possible that when implementing, you realize some flaws in your plan. So you need to first change your plan and then implement it. While defining the strategies, some of the important things which you can't visualize, they can be also uh, modeled and tested to define your modeling strategy in a more reliable manner. We need to also test the master models. Typically, for various extreme scenarios, we need to test the models. So, testing of parts can be done within SolidWorks itself. You don't need CAD, you don't need CADEC to do the part testing. Sometimes the assembly testing and more complex variations, you may need to configure the part, the assembly in CADEC and do the testing. That's all. Thank you.